Throughout some of the work that we've been doing, we've looked at area. We've looked at area of squares, rectangles, parallelograms, triangles and circles. Today we're going to focus on area of rectangles, but we're going to take it a step further. The first thing I want to just remind you is how to find the area of a rectangle. To find the area of a rectangle, we do length times width. If you're thinking of it as a formula, you'd write A equals LW because its area equals length times width. In the diagram above, the length is 5, the width is 3, so we've got 15, and the units would be centimetres squared. The reason we multiply is because we have got 5 centimetres on each row. They should be equal. I know I've not quite split them equally. And we've got 3 centimetres going across. So what we've actually got is 5 lots of 3 centimetres. Area is the space inside the shape. So that's why we multiply the length by the width, because it tells us how many squares in total are in the shape. Today what we're going to do is look at shapes that are made up of more than one rectangle. So it's not a shape like a rectangle, a parallelogram, a trapezium. It's something called a compound shape. Now, the word compound you've probably heard in science. A compound is something that's made up of other things. Okay, so a compound shape is made up of more than one shape. You won't be able to get the area just by using a formula and working out the answer. It's what we call a multi-step problem. There's steps that you need to go through and little bits that you need to do. So let me give you an example. So this is a compound shape. It's not, you might call it an L shape, but that's not a mathematical shape. It's just a shape that's made up of 2 rectangles. Now, when I find the area of this shape, I'm going to split it into 2 rectangles, find the area of each rectangle, and then add them together. But there are different ways of doing this. There's actually 3 different ways of doing it. I'll do one in detail, then I'll very quickly go through the other 2. So the first one is to split the shape into 2 rectangles. I'm going to choose to split it there. Now, this top shape, the rectangle at the top where the 3 is, this rectangle is length 3, width 4. So I'm going to do 3 times 4, which is 12. I didn't use the 7 because this length here of this rectangle is not 7. It's the 3 and the 4, and that's the thing you'll get stuck with. You've got to look really carefully about what is the length and width of the rectangle you are looking at. So if you look at this rectangle at the bottom, I want to do the length times the width. Now I can see that the width is 3, but look really carefully. What's the length? Is it the 5 or is it the 8? The length is all the way across, so it has to be the 8. 8 times 3 is 24. Now I want the total area of that shape. So 12, add 24, which is 36, and its area, so it's centimetres squared. Another method would be pretty much the same thing, but I would split the rectangles there. So over on the left here, on this rectangle, I've got 7 times 3, 21. I'm not interested in the 4 because the 4 is only that length there. It's not the length or the width of the rectangle. And over here on the other rectangle, I've got 5 multiplied by 3. So I've got 15. Again, I'm not worried about this 8 because this 8 is not the length or the width of either of those rectangles. To get the final answer, I would do 21 plus 15, which would be 36 centimetres squared. So you can see both those methods really don't matter. You can use either one. Doesn't matter how you split the shape as long as you split it into 2 rectangles. The final method you could use, I don't tend to teach, but I have seen people use it. So what you can do is you can make a really, really big rectangle. So I'm looking at this rectangle here, really, really big one. And I find the area of that rectangle. So I need to use the long lengths. I need to use the 7 multiplied by the 8. Now that would be 56. Now, I don't actually want the area of that whole rectangle because this bit here I don't want, do I? So what I do is I take that bit, this rectangle here, and I find out the area of that, and the length of that is 4, the width is 5, so that area is 20. So I find that area, and because I don't want that area, what I would do is I would take it off the 56. And you can see that gives us 36 centimetres squared, just like the other methods did. These two methods are very similar because they involve splitting it into two rectangles. This one is a little bit different because it involves finding the whole thing and taking off the missing bit. It really is up to you which method you use. All three are acceptable. It's whatever makes more sense to you and whatever you find easiest. So there are basically two methods. The first method is that you could split it into rectangles, find the area of each one and then add them together. And sometimes there's more than one way to do that. Well, the other method is to make a really big rectangle, make the whole thing into a whole rectangle, find the area of that and subtract the area of the missing section. You can use either method. What I'd like you to do now is pause the video and you try this picture that I've just put on display now. It says 9 centimetres at the side if you can't see that. Pause the video and try that question now. You might want to copy it into your book so that when you split it, it makes it a bit easier. The top rectangle is 6 times 2, which is 12. The 4 is not helpful. This rectangle at the bottom, I need to use the 7 and the 2. 7 times 2 is 14. When I add those together, I would get 26 centimetres squared. You could have also split it there. You would have got 8 on this bit, and you would have got 9 times 2, 18 on that bit, so you would have added them to get 26. Or you could have made it into one big rectangle like that, which would have been 6 times 9, which is 54 centimetres, and then subtract the area of this one here. That would be 54. The area of this bit here would be 28. And when you do that, you would have got 26 centimetres squared. Any method that you used should have got 26 centimetres squared. And as with most maths, it doesn't end there. It does get a little bit harder. And the only difference, this is exactly the same method, but the difference is they haven't given you every measurement. And sometimes when they do that, you'll have to think carefully about the measurements. I'm still going to start the question in the same way though. I'm going to split my rectangle and I'm going to look at this top one and I'm going to say, okay, that length is 6, width is 2, 6 times 2 is 12. But then when I look at this next rectangle, I haven't got this length and I haven't got this width. And what I've got to do is use the picture to work out that length and width. If I know that this length is 6 and this length is 3, that means this length has to be 3. These lines that I've just put red lines on, they are all horizontal lines. And the two smaller horizontal lines, this one and this one, they have to add up to get this bigger one, because otherwise the shape wouldn't work, it would be slanted. So because the vertical lines are vertical, those two smaller ones have to add to get that bigger one. So that one at the bottom must be 3. And in the same way, this length here, add this length here, has to make this big vertical length here. Because if it didn't, the shape would have diagonals and stuff like that, and everything is vertical or horizontal. So they will add up. So if this one over here is 2, and the big one is 7, that means this one must be 5. If we have 5 and 3, that means we have an area of 15. So the area of this shape, when I add them together, will be 27 centimetres squared. You can use those other methods that I've been through. You could have split the rectangles there. You would have still had to work out the 3, although you would have had the 7, and you would have still had to work out, or you would have been all right. So you would have had to work out less, that might have been easier. You can also do the big one as well and take off a little bit. You would have still had to work out the 5. So like I say, those other methods would have been fine. If you did it a different way but got 27, that's absolutely fine. Here's a question for you to try. Pause the video and have a go at this one. I'm going to split the rectangle here. So this rectangle, I've got 4 multiplied by 11, 44. On this other rectangle, I've got the 5, but I don't know this measurement. I can see that this one is 4, and I can see that the whole thing is 12, which means this horizontal length, that has to add on to 4 to make 12, so it must be 8. So I'm going to do 8 times 5 is 40. I'm going to add them together, and I'm going to get 84 centimetres squared. If you did it a different way but got the same answer, that's fine. If you got a different answer, what I'd suggest you do, I don't just want to keep doing the same examples, so what I'd suggest you do is watch the Hegarty video that's linked to the clip, because we're going to go on to the clip now. The clip I've set for you to do is Hegarty Maths 555. That's the one I want you to go on to do. But if you are still not sure after my video, please watch his video as well, and he will go through some more examples. Have a go at that clip. Make sure you do a memory this week. We haven't got the normal Tuesday retrieval, so it is really important that you do a memory quiz this week, and hopefully see you soon.